Welcome to the presentation. I'm Sarah. Today we are going to go over the COVID-19 time series forecasting project. Let's jump into the first part, data and project description. Coronavirus is a type of common virus that infects humans, typically leading to an upper respiratory infection. By today, there are over 19 million confirmed cases and 700,000 confirmed deaths in the world. We are going to explore the data and build a time series model on some countries and forecast on the future trend of coronavirus spread in this project. We have two datasets, includes a training dataset and a test dataset. The training data contains the number of cumulative confirmed cases and fatality from January 22nd, 2020 to May 13th, 2020 for each region over 184 countries. We are now going to process some data cleaning procedures. Firstly, we checked that there is no missing value on date and quantitative data. Then, the accuracy and precision of dataset will be checked. Since the confirmed cases and fatality are cumulative, there cannot be any decrease in value as time passes in each region. We have found those decreased values and replaced them with the average values before and after it, or replaced with previous value if the number after it is also decreasing. Lastly, the dataset is transformed into a new dataset which is grouped by region and date to help with further development. We will build models based on countries, and we are now going to choose two countries to investigate. By looking at these visualizations, we will choose China and the United States. China is one of the countries which has an early outbreak. US is now the most total confirmed cases and fatalities. I would assume that these two countries will have different trends. Let's check together. We can see that China seems to be under control now, and the confirmed cases are having a logarithmic trend. The US tends to have an exponential trend, and the confirmed cases are dramatically increasing. The package we used to forecast on confirmed cases in Python is ARIMA. ARIMA stands for Autoregressive Integrated Moving Average. It combines both autoregression and moving average models, as well as a difference in pre-processing step of the sequence to make the sequence stationary, called integration. Since we can obviously see a trend for each of these two countries, a RIMA model would be a good choice because it's suitable for a univariate time series with trend and without seasonal components. To build a ARIMA model, we need to choose P, the order of AR term, Q, the order of the MA term, and D, the number of differencing required to make the time series stationary. There are many rules relating to it, so I decided to let the machine do it for me. I'm going to talk about my implementation. For each country, the first step is to split the training set into a trained data and valid data by date range in order to measure how well we are doing for the model fitting. Then let's store all three number combinations with numbers 0 to 5. And now we can build an ARIMA model using train with all combinations of orders and save the AIC number from all fitted models. AIC is an estimate of a constant plus the relative distance between the unknown true likelihood function of the data and the fitted likelihood function of the model, so that a lower AIC means a model is considered to be closer to the truth. We always need to remind ourselves that our data is cumulative, so if the predicted value is smaller than the previous one, it will be replaced with the previous value. For each model, we will make predictions and calculate RMSE using predictions and the valid data. RMSE stands for root mean square error. It means how much error there is between two datasets. It's used to compare the predicted value with our true data. Among all the models, we will choose the one with smallest AIC and RMSE to be our final model. Then, final predictions can be made with the test set based on the final model. This is the prediction we've done for China. The result is pretty good. AR terms have a small p-value, which is significant. AIC and RMSE are fairly small. The final prediction seems to keep the number of confirmed cases steady, which is closer to the reality. The prediction for the US is also not bad. It has even a smaller AIC than the one for China, but RMSE is way larger. This might be caused by the large scales in general, and we would have a larger confidence interval. The final prediction looks very close to the reality. Let's see, these are the numbers reported by WHO today, and our predictions for today is very close to the reported value. Predictions can be done for any country. ARIMA models can be used for any time series with trend, but without seasonality. Forecast of coronavirus cases will help inform public health decision-making by projecting the likely impact of the COVID-19 pandemic in the future. Since COVID-19 can badly damage humans from many aspects, wearing a mask is an appeal to everyone. Wish you enjoyed the video. Stay safe and healthy. Thank you.